Diets are always in the news. Obesity is a national epidemic. Do you think about what food that goes into your body and how it affects you? How about interpreting the various nutritional information found in the press? What are trans fats? What are good carbs? What are bad ones? These questions will be discussed in Chapter 11, Nutrition, Food for Thought. As our world population grows, the need for food also grows. We have transitioned from hunters and gatherers to farmers and cultivators. In the process, we have started raising livestock. We now have to consider the grazing area and food, the water consumed, the energy in the process, and many other factors. The first chart on the left provides kilograms of grain required to bring 1 kilogram of different foods in the table. Notice that beef takes up the most grain, while chicken, of all the meats, take the least. The chicken is actually less than the eggs that it produces. Land is another factor to consider, both in terms of raising crops and affording grazing space for animals. It is estimated that 30% of the Earth's land surface is used for production of livestock. The graph on the right indicates the square meters of land required to bring 1 kilogram of different foods to the table. Beef, once again, is the greatest, while chicken is the lowest consumer. In the last 40 years, the per capita consumption of meat has more than doubled. It is projected that it will double again in the next 40 years. This representation demonstrates the food print for New York State. A food print refers to the amount of land required per year to provide the nutritional resources for one person. Each one of these food prints for individuals who have consumed the same amount of calories. As you can see, vegetarians only use about half an acre of food for all the food they need for 1 year, while those who eat 381 grams of meat, which is approximately 13 ounces, would require 1.9 acres of land to sustain their diet for a year. 13 ounces is less than a pound of meat. To put it in perspective, a quarter pounder is only 4 ounces of meat. Notice that eating a moderate amount of meat is maybe more efficient. It is only 1/10 of an acre more than the 100% vegetarian. So, all or nothing may not be the best approach. Instead, moderation seems to be the best option. There are other things to consider than just the land use. There are issues that revolve around water, such as pumping water for irrigation depletes the aquifers, which is the groundwater supply. Rivers dry up downstream of irrigating upstream. An increased biological oxygen demand from fertilizer runoff. There are also issues with population, such as waste from crop residues in livestock, insecticide and herbicides contamination. Finally, there may be problems with the land itself, like the erosion of topsoil or the loss of forests cleared for the farmland. We eat for a variety of reasons: boredom, celebration, stress, but the only reason that is 100% necessary is nutritional. We need to ingest nutrients for our bodies to function properly. We need water, vitamins, and calories for metabolism and energy. Unfortunately, not everyone has the capability of getting the food they need to survive. Malnutrition is caused by a diet lacking in proper mix of nutrients, even though the energy content of the food eaten may be adequate. So this might be someone who eats on a regular basis at fast food restaurants. Undernourishment is experienced when the daily caloric intake is insufficient to meet metabolic needs of a person. Although there are cases of malnourished and undernourished people in the U.S., 66% of the adult population is classified as overweight, with almost half of that population classified as obese. Obesity and its related adverse health effects are overtaking smoking as the #1 cause of death in the U.S. Think about the foods that you eat. Do you primarily eat natural foods like apples, asparagus, or maybe a piece of chicken? Or do you eat processed foods like potato chips, applesauce, and chicken pot pie? The typical diet in many countries contain numerous processed foods. Processed foods are those that have been altered from their natural state by techniques such as canning, cooking, freezing, and adding chemicals. In the U.S., processed foods are required to list their nutritional information on their labels, like the one you see here. These labels must contain macronutrients such as fat, carbs, and protein, which provide essentially all the energy and most of the raw material for body repair and synthesis. Vitamins and minerals are also listed as % daily values. We are what we eat. If we look at what our body is made of and what it takes to keep it going, and then look at the food we eat, we can start to see some comparisons. For instance, we are 60% water. We need to maintain this percentage to lead healthy, energetic lives. So we would need to eat foods that are high in water, like milk, steak, or fish. We need to maintain about 20% fat. So eating a diet that has some fat but not completely made of fat would also be important. So things to remember as far as actual calories and what that really means as far as energy. Calories are often used to express the energy released when food is metabolized. That means that when it's turned into energy and used up in the body. 1 calorie is the amount of energy required to raise the temperature of 1 gram of water 1 degree Celsius. So it's how much energy that is absorbed. This is a small quantity of energy, so we typically use kilocalories instead, which is 1,000 calories. A diet calorie is actually 1,000 calories. So when you look at a nutritional label and it says how many calories, it's actually talking about 1,000 calories. And 1 calorie is equal to 4.184 joules. So we discussed that labels tell us calories in food and where these calories come from: fats, carbs, proteins. But what do these things mean at a microscopic level? And what are saturated and unsaturated fats, fibers, sugars, and cholesterol? We will be discussing this in the next section. You are probably somewhat familiar with fats from your own life. Perhaps you cook, or you have been around someone who cooks and they use Crisco in a recipe. Perhaps you were eating a steak and you were trying to avoid the fat, so you cut around the white, unpleasant texture of the fat. You may already know the properties of fat, such as greasy, slippery, soft, a low melting point, and they're insoluble in water. Butter, cheese, cream, whole milk, and certain meats and fish are loaded with them. All of these products are of animal origins. But margarine and some shortenings are evidence of fats, that fats can also be of vegetable origin. Oils such as obtained from olives, corn, and nuts exhibit many of the properties of animal-based fats, but in a liquid form instead. The picture you see here is of stearic acid. It's the fat that you find in most steaks. All fats and oils are considered to be lipids. Lipids are a class of compounds that includes not only fats and oils, collectively called triglycerides, but also other compounds like steroids and waxes. Let's now break down what constitutes a triglyceride. Fatty acids are characterized by two structural features: a long hydrocarbon chain, generally containing between 12 and 24 carbons. This long chain is what's giving it its slimy feeling. A carboxylic acid at one end of the chain. Remember that carboxylic acid is a functional group that we introduced in a couple chapters ago. It has a double bonded oxygen and an OH group. The hydrogen atom of the OH group is what makes it an acid. This picture of a fatty acid is one with a double bond. A monounsaturated fatty acid. Mono is for one, and unsaturated is referring to this double bond. Saturated acids have all single bonds, while unsaturated has double and even triple bonds. Fats are triglycerides that are solid at room temperature, whereas oils are triglycerides that are liquid at room temperature. A triglyceride is simply an ester of 3 fatty acid molecules and 1 glycerol molecule. That's where we get the term 3 for tri, and then glycerol, glyceride. A glycerol molecule has 3 carbons, and each carbon has an OH group. As we said earlier, triglycerides belong to the lipid family, a class of compounds that include cholesterols and other steroids, and some complex compounds such as lipoproteins that contain fatty segments. Each of the 3 OH groups end up reacting with the carboxylic acid portion of a fatty acid. Here is an example of a triglyceride is made. This one takes 3 molecules of stearic acid and 1 glycerol molecule. Here's the 3 molecules and the 1 glycerol. Notice that the 3 carbons of the glycerol molecule acts as the backbone of the whole compound. Then the 3 stearic acids are attached to the glycerol molecule. In the process, notice that 3 waters are given off because 1 OH group and 1 hydrogen are being donated. The difference between saturated and unsaturated fats were introduced earlier, but here are the definitions again. Saturated fatty acids contain only carbon-to-carbon single bonds between the carbon atoms. A fatty acid is unsaturated when the molecules have 1 or more double bonds between the carbons. Notice that with stearic acid, there are no double bonds here. It would be written in there. This means that it's a saturated compound. With oleic acid, there is 1 double bond written, making it a monounsaturated fatty acid. Linoleic and linolenic acids are both polyunsaturated because they both have more than one double bond. Here's that one, and this one actually has 3. The difference of these double bonds affect their physical characteristics and the way in which they behave in our bodies. This chart shows a breakdown of the types of fats in several foods. Saturated fats appear most in items like butter, coconut oil, and chicken fat. Notice the blue area. Monounsaturated fats and polyunsaturated fats are more prevalent in things like canola oil, peanut oil, and olive oil. The difference between these two types of fatty acids affect the physical characteristics. Saturated fats are more prevalent in solid foods, solid fats, while unsaturated fatty acids are more like oils. Sometimes the saturation level of fats are altered by manufacturers. These are often publicized in the news. Hydrogenation reduces the number of double bonds by adding hydrogen and breaking the double bond. So here we have hydrogen. It was a double bond here. Now it's a single bond. The number of double bonds in a fatty acid decreases, and it is transformed from an oil to a semi-solid fat. The hydrogenation can be controlled to yield products with desired melting points, softness, and spreadability. Unfortunately, when this happens, there will be a byproduct that some products try to remove. This is called a trans fat. Take a good look at the double bond in the picture at the left. The hydrogens are both pointing up, and the remainder of the compound is pointing down. This is called a cis bond. Now take a look at the double bond on the right. The hydrogen bonds are on either side of the double bond. This zigzag arrangement across the double bond is called a trans bond. The difference becomes really important when you see several of them right next to each other. Take a good look at the molecules on the left-hand side. Notice that since they have the similar shape, they are able to stack on top of one another. This stacking is increased with interactions between the molecules. This increased interaction is why saturated fats are solids at room temperature. Now look at the picture at the right. See how the cis bonds, no cis means that they're going in the same direction. See how the cis bonds make kinks in the chain. This makes it harder for the molecules to stack on top of each other, which prevents the interaction and hence making it a liquid rather than a solid because of the lack of the interaction. Now take a look at the difference in the shapes of the cis and trans and unsaturated compounds. The trans in the upper right looks most like the shape of saturated molecules on the lower left. In fact, they are so similar that our bodies have a hard time telling the difference. Even though they were originally made of oils, they may contain more energy and hence more calories than the saturated fats. So when you see containers that say may contain trans fats, it means that it's actually less healthy for you than saturated fats. This is the end of part 1 of chapter 11. We will continue on with part 2 and talk about the other macromolecules.